Well, good afternoon, everybody. I think we're going to get started. Some people may still be arriving from their classes, but I think we have a critical mass. So welcome to this SAIS Global Risk Conference. There are several events coming up over the next couple of months under the umbrella of global risk. It's a rather broad umbrella, but certainly the concept of risk will figure in this afternoon's discussions. And we're very fortunate in having not only our own Marco Dell'Aquila with us, but also Simon Blakey and Jessie Scott, who are two very experienced experts, both from the academic, think tank, and business world, who are able to help us understand what's going on. And in the title, Climate and Energy Risk, Persistent and Emerging, what we intended was to look both at the issues that have been out there now for quite some time, and which have influenced politics, have influenced legislation, have influenced the European Union. I would say the European Green Deal was probably the leitmotif of the last European Commission, although people do feel, at least in language, and perhaps more than language, that they've backed away from that just a little bit, perhaps in response to some of the demonstrations that we've seen by interest groups in the different member states who felt themselves to be affected. But I'm sure we'll come to that. So both older risks that were addressed to some extent by legislation that's been put in place over the last few years, and new risks, because nothing stands still. The world moves forward, and we're in a new ball game. There are the US elections, we've had European elections, British elections. There are new people in office now with different orientations and different priorities. And the world moves on too, hence the title for this session. I won't go over our speakers' very impressive biographies as you had them in the introduction, in the emails that you received announcing today's events. Jessie Scott is going to speak to us mainly on the climate side, and Simon Blakey on the energy side. And then Professor Dell'Aquila will comment on any aspects of this that seem to him to be worthy of debate and discussion. Those of you who are online, feel free to pose questions in the Q&A. I'll see them here on the screen, and I will relay them in our Q&A session after our speakers have made their presentations. So to begin, Jessie, the floor is yours.
Well, thank you very much. Thank you for the invitation. We've got a combined set of slides. Simon's going to speak about energy security, and then I'm going to speak about how climate change and climate risk changes energy security. So what we're really talking about is the four main points at the bottom here, and I hope those online can hear me. I will try and stay reasonably close to the microphone, but please signal if I drift. We want to talk about how energy security has evolved as an issue in the modern world, then about what climate security or climate insecurity is, then the impact of energy on climate, and then the impact of climate on energy security. And for those of you thinking about other sorts of risks, there are obviously interlinked risks, political risk, physical risks and insurance, policy uncertainty, financial risks, transition risks, systemic risks, which we can get into in the discussion. Our aim is to do quite a brief presentation and then move towards discussion and please questions, and then we can have a really lively time because this topic can go in lots and lots of directions. So Simon, over to you on energy security. I think you'll want that.
I will, thank you. Michael, do you mind if I stand to the right of you and use this microphone so that I can point to the screen?
Wherever you're most
If
comfortable.
you can just move slightly to the left, that would be great. Thank you. Yeah, well, thank you very much for inviting us here. It's a pleasure. This is my second visit to SAIS. Jesse's been more often, I think, over the years. It's very nice to be back here. Okay, let me talk about energy supply security. The way I think to think about it is to think that there are three dimensions that policymakers think about when they hear the word supply security and energy. And these three dimensions can be illustrated by stories that we have lived through over the last 50 years. 50 years, I'm going back a long way. The truth is, of course, energy supply security has a very, very long history. There's always been a military aspect to it. It was a major element of the Second World War. The Americans among you may know that the Japanese attack on Pearl Harbor was in response to the United States embargo on the supply of oil to Japan. Or perhaps you don't. There have been a number of dynamics during wartime where energy has been central to what develops. And of course, that knocks back to pre-war situations when people are thinking about the diplomatic as well as the military aspects of energy supply. And so the first aspect of energy security, of energy supply security that politicians think about is the diplomatic and military angle. And I'll come to some details of that in a minute. The second aspect is that there are economic consequences of energy supply disruptions. And there are some important developments on that which policymakers have to take into account. It's different from the diplomatic and military things, although the links are often there. And then clearly, finally, you get concerns about public worry about shortage of energy supply. And there are specific aspects of that. In terms of the diplomatic and military leverage, there are a whole series of things that we have gone through over the period of time. And these three points that I'm mentioning, oil supply and trade patterns in the 70s and to 90s, the Russian-European gas trade, which of course recently has been a major energy supply security issue, but was also in the 1980s. And then the questions about the future. We'll go into the future with Jesse and thinking about the climate risks and the climate interactions. Concerns now, of course, are around critical minerals that have not yet been an energy security issue, supply security issue, but probably will be in the future. So those are sort of three eras that we can trace: oil, gas, critical minerals that relate to the different angles or dimensions that we need to look at for supply security. Let's take the first one first, the diplomatic and military aspect. The modern policymakers' concern with energy supply security really was triggered by the 1973 Yom Kippur War and the Organization of Arab Petroleum Exporting Countries, not OPEC, the APEC countries. It was a slightly separate organization. There was a formal embargo brought into play on the supply of oil to the United States and to the Netherlands, specifically because of US and Dutch political and military support for Israel at that time. That embargo had immediate consequences, economic consequences, as well as political consequences. And that's this kind of concern about diplomatic leverage that control of energy supply offers. We saw it more recently, long before you were born, but well into my adulthood, in 1990 when Iraq invaded Kuwait, and there was the prospect of an Iraqi-Kuwaiti combined political entity being a new dominant oil producer in the Middle East. And that mere threat, the diplomatic change that was implied by that, was enough to trigger the response of the United States and the Western world with the first Gulf War. Again, diplomatic and military leverage rather than war itself, but being a trigger for war. More recently, diplomatic leverage, in the summer of 2022, the first steps of the interruption of Russian gas supply to Europe was the Russian choice to cut supply through the northern routes to Germany, France, Poland, and the Netherlands. Southern and Central European routes, we're still getting gas here in northern Italy, across Ukraine from Russia, via Slovakia, via Austria, little bits coming into northern Italy still. There was an attempt on the Russian side to divide and rule in terms of the diplomatic leverage on the Europeans. It didn't actually work. And the response of Western side was, okay, we will do without your Russian gas as much as we possibly can, and we will embargo the imports of Russian oil as well. But it's a very recent case, of course, and one that's topical. Who knows what when we go into the 2030s, where critical minerals might be the issue. There may still well be issues around oil and gas supply, but it'll probably look very different from what it does today and from what it has done historically. So that's the diplomatic and military aspect. The economic consequences. Are there economists in the room? Do you know what I mean when I talk about the terms of trade effect? Fully trained economists, one or two. The terms of trade, a formal economic expression that defines the ratio of import prices to the ratio of export prices in any given trading relationship. The big drama of the 1970s was that the quadrupling of oil prices in 1973-74, and again it's tripling at the end of the decade, 79-80, made such a big impact in terms of the change of the relative prices that it had a big Keynesian deflationary effect on the oil importers, whether that was in the Western world or the developing world. As a result of which, you got massive unemployment. And there were two big recessions that took place in 73 to 75, 79 to 81, 82, where these, again, it's way beyond your memory, but these recessions were much deeper, much more significant than, for example, the financial crisis of 2008 to 2009 that people talk about as the most recent global disruption. And those economic consequences, of course, matter to policymakers. It's a different thing from the diplomatic and political leverage. 73, 75, 79, 81 recessions, decade-long debt crises in the 1980s resulted for developing world oil importers. It was part of a much bigger picture for them. And then, in many ways, the public impact, domestic political unrest, is the most trivial of the concerns, but it does happen, it's relevant. Cost of living, energy bills, that's been in the news for most of the Western world since 2022. There have been bigger deals back in the 1970s and 80s. The way in which some people in the United States would react to was that to the energy supply crisis was they would stand in line for gasoline. And I think at that time, 4 people were actually shot dead in rows in gasoline lines. Is that about right, Michael? Do you remember this stuff? I mean, the public disquiet could actually result in that sort of high drama. We haven't seen anything quite like that recently. But governments do take it seriously. Jesse and I were looking recently at the astonishing amounts of subsidy that were provided by European Union governments. The European Commission's figures are 198 billion euros provided in subsidy. If you add the UK onto that, you get up into the 240 billion euros of direct subsidy to protect people's winter heating bills. And that money is, for example, half the entire Indian national budget. And that sort of thing was just in response to, oh my God, our citizens might be having to pay a huge amount for winter heating. Elderly people will die. There'll be lots of bad newspaper stories. We need to throw money at it. And that was done. And that's the degree to which energy supply security in terms of domestic unrest still matters, even in recent times. So there we are. Those are the 3 things I want to leave with you, that there are these 3 different types of issues in energy supply security. There are storylines that back each of them. It's just worth having that framework when you're thinking about when someone talks about supply security, which element are they actually thinking about? One last slide I have, which just shows the change in world over the last 50 years since that first oil shock put energy supply security on an international agenda and actually created the institutions that today look at the question of energy supply security. The International Energy Agency was created in the 1970s, 74, as a response to the 1973 oil crisis, and is now about 50 years old. These figures, I'm not sure that they're legible at the back. Let me just take you through the bar charts. This bar chart is the total world energy supply in 1973. Do it that way, so I'm close to the mic. Yep.
Gently recommend that some people at the back might want to move, because there's going to be a few charts that you might want to read, so Willie, jump forward a few rows.
We don't mind.
And we'll share the slides.
As the minister would say, come forward to the front of the church, please. The point it doesn't work. I'm concerned I need to be audible to the mic for people watching and able to point to the chart. So, chart on the left-hand side, for those of you looking at it, the total use of energy in the world in 1973 and the total use today. It's in the impossible unit of hexajoules, which is the correct SI unit to use in the world. As far as I know, Australia is the only country in the world that actually does produce its numbers in hexajoules. But at least you can say all forms of energy can be expressed this way: coal, oil, nuclear, electricity, whatever. And so you have down at the bottom there, the orange thing bar is oil. And you can see that back in 1973, that was practically half of the world's energy. Today, it's considerably less than a quarter of the world's energy. And this is one of the reasons why, although there is a war in the Middle East going on and prospects of escalation, we don't have the same sort of geopolitical response and price response in the world oil markets that we had in 1973. The transformations that have happened in many ways precisely because the International Energy Agency was set up in order to diversify the Western world away from oil towards more coal, towards more gas, towards nuclear power, a little bit towards renewables, although that came in later. That has effectively had an effect of diminishing the political risks associated with oil importation and oil trade. The bar charts in the middle, the blue charts, shows the amount of oil that is used in the world now and then. And it's about doubled. It was a little bit under 60 million barrels a day. It's much more easy. You can physically imagine a barrel. It's an easier unit to imagine than a hexajoule. And today it's about 100 million barrels a day. Of course, the world population is more than twice as much what it was in 1973. So on a per capita basis, we use a bit less, but the amount has doubled. The dark blue shows the amount that was used by advanced economies in 1973. And you can see the vast majority was advanced economies in 1973. What's happened in the last 50 years is that the advanced economies really don't use any more oil than they did, but the emerging and developing economies, the pale blue chart, use considerably more than they did, and that's where the doubling has come from. Finally, the chart on the right, because we're moving from an oil world to an electricity world, the chart on the right shows the increase in electricity demand over the same 50 years. And you can see whereas oil only doubled, electricity has gone up by a factor of about 6. And where we look how the electricity is generated, the vast majority from coal, and therein is one of our big climate problems, followed by natural gas, followed by nuclear, followed by renewables up at the top, which is a mix of wind, solar, hydropower, geothermal, and sadly still biomass. That multiplying by 6 relative to the oil multiplying by 2 gives you an important signal as to where we have come from and where we're going. But you should also bear in mind that that's a figure in 1,000 terawatt hours. Don't think that the amount of electricity that's being used there is comparable with the oil demand to the left of it. To get terawatt hours into barrels a day, as every child knows, you multiply by 1.6. And 1.6 times 29,000 terawatt hours, which you can all do rapidly in mental arithmetic, is about 45 million barrels a day of oil. So 45 million barrels a day, a little bit less than the amount of energy that is delivered to people as electricity, lights, is a little bit less than half of what is delivered in oil. But it's in electricity that the issues will come in the future. And in particular, there's one point I have missed out on security, that middle chart. The developed world is using relatively less of oil, less oil than it was. The other really big difference that's happened is that the United States no longer imports oil from the Middle East. Really? No, it doesn't. The United States produces almost as much oil as it needs. It produces about 13 million barrels a day out of this 100, uses about 17 million. and the other 4 comes from Canada, Mexico, and South America. China, on the other hand, back in 1973, indeed back in 2000, was self-sufficient in oil. Now consumes about the same amount of oil as the United States and imports about 6 million barrels a day from the Middle East. The geopolitics of the trade between the Middle East and the West, the Middle East and China, has completely flipped. And if anything, it was interesting that last year, I think China sat down and supervised, brokered, was involved in a rapprochement between Iran and Saudi Arabia. Middle East matters to China now in a way that it doesn't matter to the United States. We could go into that one in more detail at some point, but that's just the sort of way in which energy supply security, how it's developed and how it's changing. That's enough from me. Jesse, over to you.
Thank you very much indeed, Simon. Very, very clear and very thought-provoking. It makes me think, in the old days, Marxists used to think that the economy explained everything. After listening to you, it's clear that energy explains everything. Geopolitics, wars, the rivalry between great powers and so on. It's fascinating to see energy being so present in all the major issues that we are discussing and reading about every day. But I'm sure we'll come back to all of that. Jesse.
Well, to make this lively, I'm going to disagree with you. No, energy, much as I work in it, fascinated by it, think it's very important, does not explain everything, because we live on a planet which is an ecological system, which is bounded by physical limits, which we are breaking in many, many ways. Biodiverse limits, but also climate limits. And those are existential. So I'm going to say one slide about climate security. I think we all know roughly what the climate problem is, but I want to frame that for then going back and looking at the implications for all the topics that Simon's raised, and really fundamentally a question of whether the future of energy security looks like the past or not. Climate insecurity. Climate change used to be referred to as global warming. If only it was that simple. Actually, it's much closer to global disruption. Climate change is described by Lord Nicholas Stern. He did a very famous report for Tony Blair. Again, this is ancient history for you guys about, it was the first big report about the economic impacts of climate change and the economic costs of climate action to limit climate change. And Stern would stand up and explain this report. And I remember being in a meeting where he'd done it many times to this audience. And he said, look, it's one sentence. Climate change is water. Too much, too little, wrong time, wrong place. Think about it. Droughts, floods, the impact on agriculture, and also some impacts on energy, which I will come to. This is a systemic risk for everything that we talk about. On the top left, I've got a little diagram of the jet stream, which circles north of the planet. The jet stream is changing because of the warming in the atmosphere. That is changing weather patterns. That's why we get different rainfall, different drought. And essentially, it's slowing. So we're starting to see longer weather patterns. And places that used to have the weather change every 2 or 3 days are now getting patterns that sit for weeks. Now, a weeks or months long drought is a different thing than a shorter one. And then you come to parts of the world where drought has been a risk every few years, you start to see it becoming virtually an annualized risk. At the bottom, we have a headline from The Economist in anticipation of one of the UN climate negotiations, the COPs. This was the one in Sharm el-Sheikh, the one before last. And they brought out a front page that said, the UN Paris Agreement goal on limiting climate change, limiting global warming to, on average, and averages of course have ranges, around 1.5 to 2 degrees of global warming, well, the 1.5 target is not within reach. We just haven't taken enough action. True. But I didn't like that headline because it sort of implies, oh, we failed, let it go. No, no, no. The response I liked was from a leading climate scientist who said, okay, we might not achieve 1.5 degrees. So we will do everything we can to limit warming to 1.51 degrees. And if we fail that, we'll aim for 1.52 degrees. Every decimal counts for the effect that we are looking at. So climate change means there is no such thing in the world as business as usual. Lots and lots of planning processes by businesses, by governments have what they call a business as usual scenario. Throw it out. It's irrelevant. There is no status quo business as usual path. What we're really looking at is either we take action to limit climate change, that's mitigation action to reduce greenhouse gas emissions, about 3/4 of which come from the energy system, energy supply and use. And by the way, energy is really complicated, but it's the easy bit compared to land, agriculture, food, demographics, the other quarter. Or we fail to take action. If we take action, we have to do enormous changes in infrastructure, in actually global equity, who uses which resources how, huge questions about investment flows, huge questions about the energy system and its operations. And if we fail, we are in an increasingly destabilized physical and ecological environment. Business as usual does not exist. And the question is how to minimize risk, insecurity, conflict, use any of those words. Essentially, over time, of course, the less action we take, the bigger the delta between successful action and failure. In other words, the bigger the risk, conflict, security problem that we face. And this chart would have looked a lot better 30 years in the past when we started talking about this stuff, and we've done some things, but not nearly enough. Two last comments on climate change. Two really good descriptions of it. First, this is a problem of Earth system physics. And the point about physics is it doesn't listen to human beings, it doesn't wait for human beings, it doesn't negotiate with human beings. This is something we're not good at as humans. We think we've got a counterparty we can talk to. Physics isn't like that. It also means that in risk terms, it can be described as an actorless threat. This is a threat that, again, is not an institution, a decision maker, a counterparty about whom you can make tactical judgments, to whom you can make offers, etc. Okay. So, the impact of energy on climate security. 3/4 of greenhouse gas emissions, that's CO2 and the other greenhouse gases turned to CO2 equivalent, are from energy production and use. The chart on the left shows you CO2 emissions rises since 1750. 3/4 of that is energy, and you can see some regions have brought down their emissions a little bit in recent years, but essentially we're on a global escalating slope. And that has implications. I hope you've all seen versions of the chart on the right. This is known as the climate stripes. The blue is what the temperature should be in a pre-industrial atmosphere. The yellow is as the average temperatures increase. The red is as we get into danger zones in terms of all of the cascading effects of climate change. And if you're born in 1950, your risk is still within a sort of yellowish range. If you're born in 2020, you are in a world where you will be 70 years old in 2090, 40 years beyond the mid-century net zero target that the scientists have told us we need, and that is enshrined in the Paris Agreement. And there are different ranges of action that make that risk deeper. The dark red is very, very scary, and it is not totally symmetrical worldwide. Alas, the impacts are going to be worse first in the least able to cope regions of the world, primarily developing countries. Okay, so energy matters. We cannot solve the climate security risk without essentially taking energy emissions to zero or net zero, because net involves some emissions and some withdrawal of carbon, negative emissions. But don't worry too much about the net. Okay, all the world's carbon emissions today, the US is big, China is now bigger, but historically it wasn't. India, as the world's biggest population, is starting to have big emissions. This is growing energy demand. As populations grow, as prosperity grows, people consume energy. India now has full access to electricity for everybody. It's not totally 24/7, but it's an amazing achievement compared to where India was 10 years ago. A lot of that is running on coal electricity. That means growing emissions. Then we have to find something. This chart Simon has shown you about the electricity mix. Essentially, the way that we deal with emissions from energy is we shift to renewable energy, which is clean, plus, in some countries, nuclear, which is also clean from an emissions point of view. And we do as much energy efficiency as possible, using energy less and better. And then we electrify our energy loads. That's your electric vehicle instead of your internal combustion engine vehicle. But it's electrification of a lot of other things, including big industries. That means it matters how we generate electricity. And today, again, coal is about 35% of global electricity generation. Coal is basically the worst CO2 emitter. And the renewables are the little bits at the bottom. We have a long way to go before electrons are clean, and we can therefore have clean energy through electrical loads. That doesn't mean wait, it means do both. Electrify the demand side, because that takes time, and clean up the electricity at the same time. In Europe, we've tended to concentrate on the cleaning the electricity grid, supply side. China has very much concentrated on the electrification of the demand side. In the Chinese city today, it's EVs. And we have to do it because, as the Fridays for Future campaigns say, there is no planet B. There is no alternative to this. Okay. How climate change and climate action also impact energy security, the other way around, because the other part of dealing with climate change is adaptation to the changes that we have already locked in through the concentration of greenhouse gases in the atmosphere. We are already seeing more extreme weather. We've all seen the headlines from Florida this morning. There are about 2.6 million households without access to electricity, with great uncertainty about when that access will be restored. Okay, that's refrigerators not working and food rotting, which is a problem when you don't know where the food's going to come from for the next couple of weeks. It's no access to bank machines, it's Wi-Fi going down, it's not being able to recharge your mobile phone, and a lot else. Here we have on the left the Hoover Dam, which is a great source of renewable hydro power. If you have the rainfall to fill the lake to run through the dam, but it's in a drought. On the right, you have grids collapsed in southeast Texas, brought down by a storm. That's one aspect of how climate change impacts energy security. It simply takes out energy infrastructure, including the clean stuff that we want more of. The other way it does is the question of how you make wind and solar, the main renewable energies, deliver secure energy supply, because part of the security discussion is about reliability of supply. And the little diagram on the left says sometimes the wind blows and the sun shines, and sometimes neither happens. There's a lovely German term for this, Dunkelflaute. It's dark and still. And this happens quite a lot in winter in Europe, when we use most energy because we're doing heating. There are parts of the world that have peak energy demand in summer for air conditioning. There are parts of the world where peak energy demand is in winter for heating. What do you do about that in a system that's based on solar and wind? We don't control them. So hydropower, if you have the water, coal are dispatchable. An engineer can decide to run that system, and they do so to balance the electricity grid. What you do is bring in increasing shares of balancing, that's trading across regions. So it may be windy on the other side of Europe, and you make sure the electricity grid can move the electrons from where it's windy to it's less windy. Flexibility, you look at the demand side, you don't plug in your electric vehicle and just charge it steadily. You tell it to charge when the electricity is cheap or green and achieve a certain battery level by 7 a.m. in the morning. And you let it download at the optimum moments. You do storage, and that comes in different kinds. The storage that balances the grid second by second matters very much. The storage that's day-night that deals with solar. The storage that deals with weather patterns, and the storage that deals with summer, winter. These are all elements that will get us, I know Marco does a lot of thinking about this, into a world where we will have reliable energy from fundamentally unreliable, although cheap and everywhere sources. Because one of the great things about renewables, wind and solar, is they are, of course, free once you have the infrastructure to use them, and you are not reliant on getting them all from an oil-producing region. Okay. Climate risks and energy risks in tension. And this is really what we want to pose to you as the overall questions. First, energy, again, that 3/4 of emissions point. Second, limiting global warming to 1.5 degrees, fundamental. Another thing the scientists say is that 1.5 is the objective because it's broadly an adaptable world. It will not look like the world you were born into. It will not look anything like the world that I was born into, but we can live with it, with, for example, a lot more air conditioning and a lot more food refrigeration. As soon as you start going above 1.5, you are in an increasingly unadaptable world. And scientists use this in a very dry way, but again, if you think about it, it gets quite scary quite quickly. Very roughly speaking, that means we've got a problem of people who think about how we forecast the decisions that we all need to make from today. Let's make sure that we have reliable heating bills in winter 22-23 because this is going to be a big political issue. And people who are thinking backwards from the net zero climate target. And very roughly, sort of if you privilege the concerns about today and postpone the climate action, you are making that less certain and more radical when you eventually get round to it. And if you privilege the climate action, you are squeezing some of the things that we are used to doing today and creating more tensions and uncertainties in the near term. And the balance between this is at the essence of a lot of the policy discussions on energy climate generally, including the security aspect. Very last slide. Is there going to be something that's a kind of new kind of energy security in the clean energy world? One of the things we have to do is think about how to redefine energy security. So the Russian invasion of Ukraine, lots of security people became really interested in gas, people who didn't know much about it, and they all come into it with a sort of game theory approach of pipeline A, pipeline B, pipeline. Can you get people who were intrigued by security game theory to think about the issues of offshore wind technologies? Who produces the technology? How the digital systems are controlled? What are the impacts if we don't have grid trading? It's a lot more granular and techy, and there's a sort of security rethink that is going to be needed. You can't take the definition of energy security that Simon's explained and just put it onto a clean, renewable climate world. And then there's the question, Simon mentioned critical minerals, of building out clean energy systems. The sun and the wind are free once you have the infrastructure, but you have to build it. And that means we're dealing with, yes, reducing fossil fuel import dependencies, great, but new supply chains. And there's a big discussion about critical minerals, which are going into grids, wind, solar, batteries, storage, and the investments and the affordability of energy in light of those investments. And questions also come in about who owns what. So Northvolt in the middle is a Swedish-based battery manufacturer that's really been a European champion of the we can do green technology. Great headlines 2 years ago, terrible headlines over the last year about how their business is building up, are they getting the investment? The whole thing may not actually go ahead. If we don't have European batteries, should we be relying on batteries from other parts of the world? Are we creating new dependencies? And it won't surprise anybody that the big headlines in both the US and Europe are about the really phenomenal progress that Chinese technologists have made and the implications of relying on those technologies. But it is a really complicated question, because if we don't, we slow down our own action, and we may have implications for the speed of the action that China is taking too. And it's one planet, and we share a carbon budget. Transitions can be very unstable. One of the best descriptions of where we are at the moment on climate and energy is we are in a messy middle, transitioning between two worlds, trying to run gas systems and renewable systems at the same time, trying to have old energy security discussions and new energy security discussions at the same time. I'm going to come back to Simon for one comment on the map on the left, because this is what you'll see in the headlines, but he's going to remind you of two things about why this map is wrong, despite it coming from the International Monetary Fund.
I'm not sure I can remember what we were talking about last night, Jesse. And what's wrong with it? Well, what's wrong with the first thing that's wrong with this map is the fact that it shows every country's individual dependence on Russia, with dark red for Austria, Hungary, and Slovakia, and so on and so forth, because it's a single market in Europe, and the concentration of demand is actually pretty much in France, the Netherlands, northern Germany, northern Italy, and the UK. And you could draw a sort of lozenge around the middle countries and say that's 80% of the demand. And what matters is the delivery to that single market, not the individual national dependencies. And yet, whenever you hear politicians talking about it, and whenever the Commission produces maps on the subject, you get these individual country-based things, and it just doesn't work like that at all. So that's the one thing that's wrong with it. The other thing, of course, is that one of the remarkable things about the last 2 years is that we had one winter where gas bills went through the roof and produced this enormous concern of politicians about people's heating bills. The global market has adapted very rapidly, and the prices are now well within manageable limits. And what's happened is that Europe's diversity that it had already established, plus the astonishing investments in the United States in gas, but also oil development, has meant that the vast amount of gas now flows across the Atlantic in ships and is delivered to Belgium and France and Britain, and that's where and actually Italy is mostly being heated by LNG that's coming from other parts of the world. So the risk that has emerged has very rapidly, relatively speaking, been got rid of. But two comments on that. One is it takes probably 2 or 3 years for energy systems to adapt to something dramatic like that. If you think back to those windows in the 1970s, they were 2 or 3 year windows, 73 to 75, 79 to 81. That typically is what it takes for any major adaptation to happen on economic terms, and we're seeing that again. Now, this, of course, is very, very different from the structural and systemic Earth physics type risks that Jesse
whereas in the political world, there can be panicked responses and there can be sophisticated responses, where the sophisticated responses say we will get there in 2 or 3 years' time. But that is not a paradigm that works for the climate risks that Jesse's been talking about.
Well, thanks very much to both of you. Energy risks, climate risks. Marco, your reaction.
I feel that you should be asking questions, but I'll maybe make some comments and then we can go to the Q&A session. To try and fill the gaps and to build on what you both said about in the global economy, if we look at carbon abatement, the energy sector is the bad guy. Within the energy sector, the electricity sector is the single largest contributor. And it's also the sector that has had the most decarbonization work. So if you look at both the data that you've used, the growth of renewables has been significant and impressive. And I show my students this every year, but I'm going to be slightly contrarian. I think that what we've seen over the last 20 years since I've been involved in the energy sector is the mitigation or abatement of the lowest hanging fruit. So we've done what we can do reasonably easily with the technology we have by using aeroderivative jet engines to bolting them to the ground using gas turbines. And gas turbines, the energy is less carbon intensive than coal. That was easy. We've also developed wind turbines, which have had windmills for 1,000 years. And all the stats we see, when you look at those stats and you look at those bars and you think there was 0 and now they've become 30 and 40%, psychologically you think, well, give it another 10 years and we can just keep that gradient going. And one thing I want to challenge you all with is that actually it's going to become much, much harder. Sometimes you hear about hard to abate sectors, so they're industries that need to reduce their carbon intensity, but the processes that they need to use to do that, electrification, are very expensive and not available at scale. The grid does not exist today to be able to convert your electrical-based system from a gas and oil system. When you think of investors in the 1970s, or actors in the energy sector, they were mostly government-owned, state-owned. German, Italian, certainly BP was, British Petroleum. Today we have a different market. We have private sector-driven companies that need to raise capital, and when you have shocks, I think in the 70s those shocks were severe, but they were controlled by government actors, by central banks. Today, you have the risk of contagion that you didn't have, because the minute a company doesn't have access to capital to repay its investments, that can cause contagion in the whole sector and affect French, German utility and American utility, etc. Although there is a side argument that maybe in the emerging world, and certainly China and India, you have many more state-owned utilities. But if we look at the core of the discussion today, it's about risk. And I'm going to say, introduce that the private sector introduces a level of risk that we didn't have in the 70s. And the risk of contagion, you mentioned 2008 and 2009, the financial crisis wasn't as bad economically. But what it taught us was that a relatively small problem had a massive effect in the global economy to a much greater degree than it did in the 70s. Number one point. So it's the risk of contagion because of who owns the assets. The second point I would like to make is that and this is from an investor practitioner's point of view, when you invest in an asset, it could be a pipeline, it could be a transmission line, you want your money back. And whether you fund it yourself or you get debt, you've got 15 years, 20, 25 years to amortize investment. The longer the period that you amortize your investment, the cheaper it is. So infrastructure as an asset class from an investor perspective tends to be long-term investments, which pension funds like to invest in. However, when you look at supply shocks, energy risks, they're very sudden, black swan events, it's very difficult to predict, and that can have a catastrophic effect on those investors who have spread their investment over a very long period of time in order to make energy, water, more essential utilities affordable. So in a private investment market where you have increasing risks, systemic risks, deeper impacts, as Jesse mentioned, how do you mitigate? Because I think we risk having small events that could trigger systemic risks that could undermine the investment that we need to make. So what we've had is very elegant sort of policy-driven rationale, and I'm trying to give maybe practitioner, investor, utility that has to react to these policies and put in place frameworks of investment that have to last 25 years. We've mentioned transmission. Transmission is a very boring sector, but it's in the energy sector is one of the most important things. When the transmission system was built 100 years ago, and some people say it's the biggest global infrastructure we've ever built, globally interconnected, or at least regionally interconnected. If you look at London Sea Cable, it is almost like a global interconnected asset that all works. Because when we flick the switch, it works. Industry, it's incredibly effective infrastructure, but it was built around coal plants, and it was built initially when these coal plants were in cities. Then it evolved to coal plants, which are large scale, thousands of megawatts of production capacity in remote areas, feeding large cities. We're now moving towards an electrified system based on renewables, where these renewables are somewhere else. They're in the middle of the sea. They are in Arizona, whereas the demand centers are west and east coast. So dealing with creating a new grid to take advantage of this renewable resource is a massive challenge. And just as a proxy, for every dollar, euro that you invest in a wind farm, you have to invest at least, and this is a very rough proxy, at least one, if not more than $1 to reinforce and rebuild the grid. Once you've rebuilt the grid, you have to amortize it over 15 years. So one of the other things we haven't talked about is technology. We take for granted the policymakers put policy in place and technology delivers the solution, which is be wind turbines or photovoltaics. And in the future could be, nuclear fusion, something I've worked on, not in the next 20 years. But for technology to come and to be commercially viable, you need incentives to be put in place. And those incentives historically have put a lot of burden on consumers, especially in Europe, to pay more for their electricity. And now that we live in a macro environment where interest rates are high, although coming down Europe, not so much UK, and affordability is a massive factor, to what extent in the future will policymakers be able to just pass the cost of new technologies on to consumers? Sort of. I'll leave it at that.
Thank you very much, Mark. The investors' eye view. Jesse, I know that you want to come back, but I'm just looking at the watch and I see we have 25 minutes left. I mean, if you'd like to come back very briefly, and then I'll open up to Q&A.
Very briefly then. Totally agree with you. The hard stuff is ahead of us. It's not irrational to start with the easier stuff, but it's also politically more convenient. So absolutely the electricity sector, because it matters, but also because it has relatively few jobs, it's relatively public sector, and it's very easy to regulate and monitor. And I remember when I worked for the electricity sector in Brussels, explaining that it didn't matter what the EU climate target was for 2030, our sector was decarbonising. The question was whether everybody else was and how much electricity they'd be using. In other words, my members should want a high target, because that's a win for them. There was no low target option for electricity. Two, you won't get any disagreement from Simon and me that private sector globalization changes some of the dynamics. And one of the key examples to think about here is the insurance sector. Well, they're big investors like pension funds. They're also risk analysts by profession, and they are incredibly climate exposed. Imagine what Florida means for the insurance sector. So they're dealing with all three aspects of this and trying to figure out how to navigate being investors, being insurers, perhaps not wanting to insure some of their own investments. I'm speculating, but you can see the problem space. Last one, affordability. Yes, we are going to face, because we need to invest, affordability issues. But that's not just in the rich West. 7/10 of the world's population lives outside the rich West and China. Those 7/10 see a tiny fraction of energy investment. And that's why when Europe talks to India about climate action, the Indians say, we'll talk about our coal when you talk about your oil consumption and your lifestyles. Because we're a developing country. We've only just got electricity to everybody, and you're coming in and telling us to shut down coal while you're building bigger and bigger SUVs and driving them around. So the affordability issue has global equity implications.
That's a very vivid example. Thank you so much. Okay, well, you've heard a great deal, energy, climate, the investor perspective. There's also the whole political dimension that we haven't touched on. So please feel free to ask any questions or make any comments on any of what you've heard. You'd introduce yourselves briefly, and also those following online, please put your questions into the Q&A.
Good afternoon. Thank you, everybody, for coming. Going back towards the beginning of the talk, I recognize there's likely a lot of unknowables, but I'm curious as to what your projections might be regarding critical minerals in the future. And I know it's there's a certain lack of value perhaps because it's speculative, but it's so interesting. And my understanding is that with the rare exception of maybe coltan being sometimes sourced in places like Australia, that most of the critical minerals are going to be coming from Central Africa. And I don't know if that's correct or if it can be complicated, but I'm kind of curious what some of the ideas for the future might be.
I think the backup charts, if you want it.
Yeah, the backup chart has a long list of critical minerals, on none of which I'm an expert. So we can leave the chart. I mean, it's a good question, and it's a complicated area because there are so many different components. But it's there will be geographical dependencies, but they will be more varied than the Central African one that you mentioned. I mean, copper in Chile and elsewhere, a great deal in China, as we well know. Curiously, one of the crucial minerals in batteries, I think, is petroleum coke. So you actually need oil refineries to be able to produce it. It's not just there's a whole list of things. Lithium, there's a big project in Serbia, which Europe is relying on heavily, which may or may not get authorized and go ahead. The complexities are immense. The geographical dependencies are really quite wide, but they remain geographical dependencies. I think out of, if I drew one big message from Jesse's talk, it's that really it's extremely important that we develop peaceful and cooperative relations with China in the West. I mean, it is so much not on the agenda at the moment, and yet if you are talking about the sort of climate risks and the fact we're dealing with a single Earth system's physics, it's very, very important to make sure that the relations between China over the next 20 years and the Western world over the next 20 years are not hostile. Probably the central issue.
Mark.
Can I add a tangible example? The reason why we use lithium-ion batteries in large-scale utility applications is because they were developed for mobile phones. And we, the public, spend lots of money buying mobile phones, which helped to fund the technology, made it smaller, more efficient. So massive amount of investment was made in lithium ion initially because the technology was small scale and could fit into a phone, and the phones got ever smaller. Because of that investment, you transitioned the lithium ion battery from the phone to your car, and then from the car into utility scale batteries. Now, the reason I'm talking about utility scale batteries is if you look at the transition to an electrified world, you'll need more batteries. And the scale of utility scale batteries is much greater than in mobile phone use. So you've had something that's developed for mobile applications being used for utility because the investment was made by us buying phones. But that's not the best technology to use for for large scale utility batteries. There's solid oxide, possibly. There are other technologies, manganese batteries. There are many other mechanical, there are dozens of different batteries. But why don't we use them? Because they're not commercialized enough. They're not produced in large scale. And so that is the challenge that we have to face. So we have rare earth minerals. They give rise to the lack of supply in globally stable or regional economies, which would then need to push universities and research centers to focus on technologies that don't require those, or maybe require other chemicals, rare earth minerals that are available in the jurisdiction. But that's very hard to do because consumer-driven technological change can fund a lot compared to how much governments are willing to fund research. So that's a dilemma that we face. If you dig around and look at universities, that you will find the technology, and it will be a very effective technology, but it's not a commercial technology, and you'll need years and years to demonstrate that technology. And who's going to fund that? And then you have the value of death problem. Out of university into companies, who's willing to fund that? So I think that's a big challenge we face. Mostly the technologies exist, and I use nuclear fusion seriously because we know the process works at a micro scale for a few seconds. What we haven't solved is the engineering problem of being able to operate plants that last for hours, days, months, rather than seconds, which is an engineering problem, not a technology or innovation problem. So I think if we look at the policy aspects, how much we invest at University Research Centre is as important as how much we worry about the geopolitical elements.
Thanks, Marco. Other questions?
Just from last year's NEDP class. So I think two things. The first one is, how do we handle all of this? How do we take this forward when there's these conflicts going on? I mean, Middle East, Ukraine. It's difficult to understand how it's like, it feels like this isn't getting the attention it was getting before the Russian invasion. That's the one thing, and then the other is just recently all of the big oil chiefs and bosses have decided they're not going to go to Baku for the COP26. So that's sort of like an even further digression of progress. It just feels like, and then when things were going well, we had the biodiversity laws enacted by the EU, and the farmers were driving their tractors through Brussels. How do we handle like trying to do the right thing, but then balancing so much bad all around? I know it's a weird question, but just good thoughts. Thank you.
Jesse, perhaps, or
I would love the UN climate process to actually be in charge of solving this, because it would mean there was one place where everybody's represented. Actually, the things the UN can do are set frameworks, about goals, ensure that dialogues take place, raise issues, but action ultimately is a mixture of, in the policy field, what nation states do, and some of them have massively more resources and global contributions to make than others, and of what is going on, totally agree with Mark, in the commercialization of the technologies that are different. There's not a lot that the UN COP can do about that. So they're fascinating events, but whether all the world leaders turn up every year is not actually, I think, make or break on this. Plus, we have had the modest political success that we now have climate pretty much mainstreamed into all of the big global summits. So the G7 has a climate bit, and the G20 has a climate bit, and the Shanghai Cooperation Process has a climate bit, etc., etc., etc. So global negotiations, yes, in terms of making sure that there are good relations in which climate, by the way, comes at the top of political priorities between major global actors, but the detail of the negotiations, less important.
Yes, I think I too would take a slightly more positive, from the geopolitics of it, a more positive tone than a more positive angle than the tone of your question implied, precisely because of that point. The UN process isn't going to solve everything. It's not a sufficient condition by any means, but it is a necessary condition because it does mean that climate is on the Earth system physics question is on the agenda of political leaders in addition to traditional geopolitical concerns. And if you have a list of 5 things that are at issue between the United States and Europe on one hand and China on the other, if all 5 of those are potentially conflictual, that's a bad thing. If there are 6 and the 6th one is, my God, we actually have to cooperate here, we both recognize that. That's a good thing. That doesn't mean there aren't problems. There are 5 problems, but there's one area where we know we must cooperate on the problems bigger for all of us.
In a word, implementation. So we've had climate summits for decades, and they've achieved a lot. But as Jesse said, they set the frameworks, which then governments have to adopt. Governments have adopted. You probably a shining example, not quite a government, but let's say. But now the challenge is no longer in the hands of governments, but in the hands of companies. Companies must implement. And if over the last 2 years, one thing is that the commitment to net zero that a lot of companies have made is reducing. In one of the businesses I'm involved in, which produces green hydrogen, which is very esoteric, but anyway, it's an alternative to electrification. We feel that the support government is giving in the UK and in Europe is diluted. Companies have decided that 2030 goals aren't that important anymore. We have clients that had all these commitments on their websites. We've actually taken screenshots, and I can't mention who, a very large brewing companies, global brands, that had all these global commitments, and over the months, and literally over the last 18 months, have begun to take them from their websites. So large corporates must carry the can. They aren't doing as much as they should. We have a mutual friend, former student of mine, who is maybe one of the leading lights, where he represents a large corporate, Google, and they're at the forefront of pushing climate sustainability, decarbonization, but they are an exception. Most of the people that we deal with in my company have said, maybe not 2030, but we'll still have our 2050 goals. We'll just adjust our trajectory. So what's worrying about this is that flies in the face of just analysis, that it's physics, it's not decision making. So my point here is we've had some carrot, not enough stick. And if one sort of question or challenge to policymakers and governments is to apply more stick, to force companies to decarbonize and to enact the decisions made in global frameworks. Don't forget, a lot of those frameworks made available billions. And if you ask most, most of those involved in those COP discussions, very little of the funds have actually been dispersed. So implementation.
Well, we'll open up, but I think there's some more questions.
Sure, yeah. It's just related, so that's why I want.
Sure. Maybe as time is moving, we'll take a couple of questions.
Hello, yeah, I wanted to ask about that.
Introduce yourself.
Yes, my name is Tom, and the reason I wanted to ask is, I'm from Canada, and Canada as in general doesn't, produce that many emissions relative per capita, we do obviously, but we're not that big of a population, but I've been thinking recently because the probable next of our governments, who's gonna probably be the Conservative Party, their big thing is getting rid of the carbon tax in the name of, daily affordability. It's not true, but neither here nor there. So I'm thinking about that question of sort of the political side of it. There is a scientific consensus on climate change, but there are some big exceptions nationally when it comes to like the Republican Party in America. Is the sort of global political leadership on this being incoherent a problem for like investors? Because obviously, or in general for any of these issues, because yeah, as I say, sorry, I lost my train of thought slightly, but
It's pretty clear.
yeah, okay, great, okay, I'll move on then, but
Let's
yes.
take a couple more and then we'll have a final round.
Hello, my name is Adam. My question is about, I guess, building on that, like how we force countries and companies to respond in at a scale that's actually effective. Like we were talking at the beginning of this about those three levers of risk, right? And all of our panelists have said that cooperation is a big important part of this, but that the first two, as far as I can remember, levers mostly dealt with reactions to conflicts. And so it seems like my question is like, how do we get these governments to cooperate when really the incentive structures and risk structures are in place where they'll innovate the most when they're at conflict?
Okay, thank you.
Hi, my name is William. I'm from the US. My question is related to Max. Is your name?
Me?
Yeah, Tom. Sorry.
Okay, not a three-letter one.
From Tom's question with like conservative politics, if Trump wins the election in November and there's 4 years of climate denialism coming from the United States, like or pulling out of Paris, which will probably happen or certainly happen. How does Europe and other parts of the world respond? Like, is that obviously the negatives are pretty apparent, but are there any positives that like, focus on sort of like industrial sovereignty, which is kind of a buzzword nowadays in Europe? That like, is there potential for greater leadership and action in a response, or is it just like lost time?
Okay, and a final question.
My name's Ian. So I noticed that nuclear wasn't really touched upon in any of the presentations. I was just wondering if it's nuclear in general, it's a viable option to solve either of these problems. So.
Okay, well, there we have a range of questions, so I suggest we just do a little round and please respond to whichever one of these questions you'd like to address. Simon.
I'm planning to synthesize one response to all questions. Tom, on global incoherence of governments, and it's sort of linked to what if there's a Trump presidency. I would worry a lot less about that than about other things, because, and in defense of the companies that I advise, that Marco has dissed. The CEOs, the senior managers, and the people who work for these companies, they know the scientific consensus, and they're not going to be seduced by silly stories. And they know the science. They also know the engineering, and they know the time it takes to roll things out and the investment context. And when they came out with 2030 wish lists, they probably knew
this is hopeless, we can't do this by 2030, and now they're facing the reality of having to row back from it. But they do know that this is serious, and they will continue to stay engaged regardless of a 4-year Trump presidency. And I think that's as true of American companies as it is of European companies. They also know, as well as knowing the science, the engineering, and the rollout times, they also know the competition. The fact that if I, as company A, pull out of something like an oil well development, this will only mean that unless consumers consume less oil, somebody in Indonesia or Nigeria or Venezuela will produce that oil, and it will be moved to that consumer. And this is a real challenge for industrial concerns about industrial sovereignty, etc. I mean, when, for example, the British government and the new British government will probably has maintained very high tax rates, which will reduce North Sea production. Not now, not next year, but in 4 or 5 or 6 years' time. Will the British consumer be consuming less oil then as a result of that? No, they'll be importing it from Nigeria instead. So, but can you, as a government, not do something that you think is within your power because you think the consequences are irrelevant? Probably not. You have to make the political choice. But the industrialists know. They do know that the competition will happen that way, and they are adapting to a reality of what the consumer does. And this is where I would think, it's all very well to point at government policies, at industrial strategies. Actually, it's lifestyles that make the difference, and it's the sheer size and scale of the world's population that's the biggest challenge. And then finally, there was a point about innovation and conflict. And that, I think, is a really seriously difficult one to answer, because it does tend to be true that most innovation comes in conflictual situations. And that the technological progress that we get, sometimes it's because the mobile phone spreads and you get an innovation. Sometimes, frequently, it's military, the aeroderivative engines that you mentioned that we've tied down that actually have reduced massively American CO2 emissions. If you look at the chart for the United States, since 2008, United States CO2 emissions have been coming down, regardless of whether it's an Obama presidency or a Trump presidency or whatever. It's because they have been using aeroderivative engines tied down to generate electricity, and it's substituted much more efficiently for coal. And this has meant that the US is actually something of a climate leader, regardless of whether it's in or out of COP. Just look at the numbers. And so that is, but where did the jet engine come from? Warfare. So you have a really serious philosophical point there that it is a challenge, that innovation does tend to come from conflict, and innovation tends to be the route to the technologies that we need.
Thanks, Simon. Justin, if one of you would address the nuclear question, would you do that?
I talked about fusion, I'll talk about fission.
Justin.
Well, make one quick remark on nuclear. I sat up all night about 6 months ago with a friend who is an expert on the world nuclear industry, and learned that there are 48 nuclear power plants under construction at the moment in China. That is actually an opportunity to demonstrate something that's never been demonstrated about nuclear power. Regardless of your beliefs on the subject, nobody has ever built a nuclear power plant on time, on budget. It's possible that this is about to happen at scale. That changes the nuclear offer in this space really, really clearly. Now, then you get into whose technology and where the uranium supplies come from when you're back in the energy security box. So keep watching this one.
Just use fusion instead.
Actually, the answer is usual climate and do both. Please don't bet on one horse. It would be insane. There is no planet B. Second comment. I think it's very clear, I agree with Simon, that both for companies and countries, it's really pretty obvious that in the medium term, and the question is how short term is the medium term, in the medium term, winners will be those who invest in low carbon throughout the economy, including circular economy and recycling as part of critical minerals, and clean energy. Those who don't will be in a less favorable position pretty soon. The question is, nobody wants to be absolutely first. Everybody wants to be in the sort of top 1/3. Nobody wants to be at the bottom. And this is where policy can matter. It doesn't shape everything, but getting coherent policy signals can help people be clear about where the front of the wave is and the speed at which it's moving, and therefore where they want to put themselves. Third point, global regions are framing the question a bit differently, I think, at the moment. So in Europe, we're approaching the EU Green Deal 2. That's not got quite the same political flavor and narrative to it that we had in 2019. The positive framing of it that I like is Europe is thinking about how to re-industrialize, maybe old industries, maybe new industries, based on green electrification as the backbone for an industrial development. The US is thinking a lot about clean energy and geopolitics, maybe too much. It should be thinking about a bunch of other things as well. India is asking itself, as are many other countries, about green development. How do you go from being a $3 trillion economy to a $10 trillion economy in a way nobody's ever done it before, on a green pathway? That matters to all of us. And China is asking itself about the sheer rate of change in the scale of the Chinese economy that are implied by the Chinese targets. This is partly an engineering question. A friend of ours calls hard engineering facts. You can't do major civil engineering projects by waving a magic wand. Last comment about cooperation and conflict as a driver of innovation and action. Two small things to comfort you, maybe, because I think the question's right. Simon mentioned the military. The military are really good at innovation. They are really good at deployment. They're really good at risk analysis, and they're pretty influential. And they get climate change. So one of the groups, Trump or any other climate skeptic populist has a problem with today is their own military leadership, who are also pretty good at outlasting politicians who come and go. Last point on this is a quote from a Chinese friend of mine. He came to work with me in a German think tank, and he has, from his graduate days, a Canadian passport. And I said, why choose a European organization to work with? You know, you've gone to work in Beijing, you are moving back to China because it's important and you want to be part of the process. Why do that with a European think tank? And he said, because I think you need both democratic processes and coherent over time central planning processes to address climate change. And I think Europe's got an interesting and positive combination with the European Commission, which is fairly steady state, and little swings in European politics don't really change how the train runs down the tracks out of Brussels, and the sort of innovative democratic feedback space that we are starting to get into on climate action, from his point of view, that made Europe politically interesting. So let's hope on that one too.
You may be optimistic, Jesse, about the steady state of Europe, but let's see. I hope you're right. We've run out of time, but Mark could briefly perhaps some final thoughts.
Two final thoughts. First one about nuclear. Nuclear is nuclear, the building of nuclear power plants is a regional game. China very good at it. The US have stopped doing it, but broadly build out at a slow rate, and Europe is terrible. And the reason for that is correlated to building standards and health and safety. China has none, the US have low, and Europe has high. So that is the reason why you have different build rates. So if you build a nuclear power plant to European standards, it's going to take you 20 years. Now, I'm not saying the European standards are must have, but they are where they are, and so it's going to be difficult. Do we want nuclear fission in a decarbonized world? Yes, technically, because it is decarbonized, so long as the other risks associated with storing nuclear waste can be dealt with. In the 1970s, nuclear was seen as what sort of cataclysmic risk, something that many Italy voted against, Germany voted against. Today, looking at that risk in the context of other risks, it seems less of a risk, and therefore it's the perception of risk. So today it's becoming more acceptable, given the problem of actually building it, but taking that to one side, less of a risk than the risks that Jesse has discussed, which are sort of existential to our existence. My last final point on politics. Last 10 years in the energy sector, I would say one of the biggest trends that I've seen, I mentioned one, which is the move from government supernatural national policy making to companies taking and running with the, let's say, decarbonization and shift towards renewable. And the second big thing that I've noticed in these last 10 years, politicization of energy. So I would say 10 to 12 years ago, at least in Europe, I can't speak for the US, broad consensus. There were always debates on the side, mostly to do with government forcing individuals to do things, but not broadly about where we needed to get to. It was more the how. Today, it's a very polarized debate, and that happened in the US and contagion to Europe, and is broadly sort of anti-net zero if you're on the right-wing camp for, you know, using an old paradigm, and for in you know, for the left wing. This is not very helpful, because the problem is one about physics, it's not about politics. And so how we break from that, I don't know. I'm not paid enough to opine on that.
Well, thank you so much. Please join me in thanking our speakers. I learned a great deal, and I hope you did too, and we look forward to continuing the conversation. Thank you so much for coming to Bologna.
Thanks for great questions.
Really.
Thank you. It's a very nice.
Great.